Okay, so today's topic that I'm going to discuss is class template, or we called it generic class. Generic class. Now let's first understand what is the need of this kind of template classes, and how can we incorporate class template with function template that we have discussed yesterday. Okay, yesterday we have give our more time to understand the need of function template. And yesterday we have mentioned that mm, function templates are more useful when we want to use a same logic, or we can say in short, we can say it's algorithm, same algorithm, irrespective of any data type, and we have found that where it is most useful. Suppose you are writing an algorithm, sorting algorithm. We have implemented not much in the classes. We have implemented very basic sorting algorithm called bubble sort. And also we have implemented a searching technique, most popular searching technique, binary searching. It's a divide and conquer approach. We have did it in both the problem using integer array, correct?
Yes, sir.
Integer array. So what we have understand yesterday, that function template is one of the powerful feature available in C++ programming, which provides us a flexibility that one algorithm can be used with various data types. And during the discussion, one question, a student was asked a question that, sir, same thing we can achieve by writing a normal function. Like we're writing a bubble sort for integer array. If we write the prototype here, if we remember remember the prototype, so void bubble sort, then we are writing this array and integer size. This was the prototype of the bubble function, bubble sort function. So if we look at the prototype here, it is useful with integer only. Now, suppose that a programmer or say a user wants to use the same function that you have written for float type, then what we need to do? We need to write another bubble sort function. With different type of argument. So this is called what? This is called function overloading. A function name is same, but type of argument is different. So now think about float. Now think about double, character, string, object of a class, array of an object of a class. To perform bubble sort, we need to write 5 to 6 bubble sort function, and only one change we need to do always. The argument type need to change. In other case, our logic will be remain same. So we found that in function template, if we adopt function template mechanism, we'll write only one function. If we remember the syntax here, template, after defining a type with a template, and now if we write here bubble sort, and then template type you are using, an array will be again of template type, and size of the array is always remain integer. So we found that this template function is useful over any data. Rather, defining multiple functions for same job, use one function irrespective of any data type. So when you're going to call this function, this sorting function, suppose I'm calling calling this function here. Then we can pass an integer array. Suppose previously an array is declared with 5 elements. 5 elements are there. Yes. So we can pass an integer array. Rest of the thing you should left for compiler. Compiler will do. How compiler will generate this T2 integer? It is the compiler headache. It is not in our headache. So we called it a specialized version will be generated by the compiler, and this is the reason we call template function is also called generating function by the compiler. So now think about this algorithm. Now think about, we can write so many sorting algorithms we have. We can apply over a group of elements. We have bubble sort. You're going to learn everything in third sem as part of a data structure. Bubble sort, we have selection sort, we have insertion sort, we have quick sort, merge sort, radix sort. There is various other sorting algorithm, and all those algorithms are designed for specific purpose. We cannot use all algorithm in all type of application. All sorting algorithm have its own specific application. It is designed for a specific application. So this part will be discussed in your upcoming semester by the respective faculty. Now think about, you want to put all the sorting algorithm together. Okay. And you want to build one application called sort your problem application. You want to design an application, a software you want to design. The name of the software is sort your problem. Here, user will identify what type of sorting algorithm is useful for his or her problem by seeing his problem definition. So this application, what is the requirement? Requirement is that you should write implementation of all the sorting algorithms put together. And we know that C++ provides us very perfect mechanism for this. We can create a class called sorting your problem, name of the class, and we can design the member functions. One member function will be bubble sort, another member function will be selection sort, another one will be insertion sort, and then quick sort, then other sorting we can implement using member function. So what I want to actually tell you that we will use a template class by which we can provide the generalized version of similar type of algorithm, similar sorting, they're under one category. That's why I'm saying similar type of algorithm, similar type of algorithms, okay, under one umbrella. Might be my spelling is correct. Okay. So this template class provide you this basic powerful features to you. It's provide you this mechanism. You can write more number of template function. Now it is asking from the user side, put them in together. So how to put them? We put them inside a class, and that class will be a template class. So problem definition is clear. Any query regarding the problem definition? Any query regarding the problem definition?
No, sir.
No, sir.
Okay. Now let's move further. Let's see how to create a template class.